Okay, we're continuing on for the rest of the assignment. We're on page 6 of 13. Well, 5 of 8, depending on the way you look at it. And we're on question number 9. We just solved this for r. Solving for something. Solve the equation for r means I get r by itself. Just like if I had x plus 2 equals 5. If I'm solving for x, I get rid of the 2. I end up with x equals 3, right? When x is alone, I'm solved for x. This is the same thing. The only difference is there are not numbers involved. So solving for something is the same thing as isolating it for that variable. Okay, the equation 25x minus 5y equals 30 is in standard form. That's true. We're going to transform it to slope-intercept. As a reminder, standard form is ax plus by equals c. And slope-intercept is y equals mx plus b. Okay, so what we're doing is we're turning one into the other. Okay, we're going to do it with numbers. Notice slope-intercept always has y by itself. Standard form has something times x, something times y. It's a number by itself. X and y in all of these are variables. Everything else is just a number. So these are general. All I have to do is replace the letters with numbers. Each of those letters other than x and y. So all I have to do here, if I want to turn it into slope-intercept, is I need to make sure that this y gets to there, and everything else gets put on the other side. So that's what we're going to do using algebra. Here's what it looks like. 25x, I'll change this back to black because I like that more. 5x times y equals 30. So I want y to be by itself, so I need to get rid of the 25x and the negative 5. Just like before, we're going to add and subtract first. 5 is being multiplied by y, so the only way to get rid of it is division. I'm going to get rid of these guys first. I'm going to take away 25x's from each side. Here's what it looks like. And that's 25x. Move this guy over a little bit. There. And so we end up with 25x over here is gone. Equals 3 minus 25x. Okay, so now I got rid of that. Now the y is almost by itself, like it's supposed to be. And get rid of this negative 5, so I'm going to divide everything by negative 5. Remember, that means everything, each term. There are 1, 2, 3 terms. When I multiply or divide, I have to do it to all of the terms. So what's that going to look like? Let's do it. I'll push it in there. I'm going to divide by negative 5, divide by negative 5, divide by negative 5. Clear these guys. All right, so now this is going to be fun. When I divide a negative by a negative, it makes a positive. So negative 5 divided by negative 5 is just positive 1, or just y. Negative 5's cancel out. Now here we have 30 divided by 5. That's by negative 5, so it's going to turn from a positive 30 to a negative whatever 30 divided by 5 is, which is negative 6. And then when I divide negative 25 by negative 5, the negatives cancel out, and you end up with 5x. And guess what? We're done. The only thing left to do is switch them around. Looks like this. Y. Instead of putting the negative 6 first, I'm going to put the positive 5x first. Now, in standard form. I think I can do it this Forgot I wanted to remove the other stuff. There we go. All right. And that's the answer. We just put it in standard form. We went from this form to that form using algebra. All right, great news. And if I graphed these, they'd be the same thing. Why? Because I didn't change the equation. The equation still says the same exact thing. It just has the numbers in different spots. Okay, we got this equation. We're going to find the time of death based on body temperature. Now, I'll tell you this is not exactly right because temperature changes based on, it's an exponential function. It's different. It's weird. So this is not exactly correct, but we do this later in science. Certainly, scientists check the body temperature to see how long it's been dead. The equation 98.6, that's your original body temperature, minus F over 1.5 equals T, approximates the time of death based on body temperature F. Solve this equation for F to determine the body temperature of T after T hours. Okay, so F is how hot the body is, what the temperature is, and T is how long that body has been a dead body. Okay, so we're going to solve for F. So I'm going to take this whole thing. I'm going to have to move F to it by itself. I'm going to have to get rid of the 1.5 and the 98.6. So let's do it. Let's see. I'm going to have to type it. It's going to be annoying. That's going to be what it is. I'm going to do it over here so it fits. 98.6 minus F equals T. The bottom line is divided by 1.5. Now, very important thing to remember is that when something is on a fraction, that's the same thing as parentheses. So these two numbers, they're in parentheses. They're both being divided by 1.5. So I cannot get rid of this guy. Even though we usually start with addition, this guy's inside parentheses, technically speaking. Okay? You have to remember that about all fractions. If you have something on a fraction with something else, they're technically in parentheses. That fraction bar is kind of like parentheses. So this is all one big thing. Okay? So I need to get rid of the 1.5, which is outside of the parentheses first. All right? So I'm going to multiply everything by 1.5. And I'll put it over here, right here too. 1.5. What I end up with is that these cancel. I end up with 98.6 equals 1.5 times T. Oh, sure. Now I need to get rid of the 98.6. How am I going to do that? Well, I need to, it's being added to negative F. So I'm going to subtract it. Minus 98.6. Okay. I'm going to subtract it over here as well. Minus 98.6. That's going to leave me with nothing but a negative in front of the F and the F itself. Negative F equals 1.5T minus 98.6. All right, now I just need to get rid of that negative in front of the F. The way I do that is by multiplying by a negative, because a negative times a negative makes a positive. They cancel out. So I'm going to multiply everything times -1. Everything. Remember, when I multiply or divide, I multiply everything. Each term, this guy, and that guy. Which means everything's just going to switch sign. I give you permission for the rest of mathematics. If you make sure to change every single number, change its sign, that works. I changed f from negative to positive, 1.5 from positive to negative, and 98.6 to positive from negative. I switched them all. And now we have solved for f. So if I want to know the temperature, wait, no, I wanted to know the temperature. If I know how long a body has been dead, I can guess what temperature it will be. Because I can plug in how long it's been dead, multiply by negative 1.5, subtract that or add that to whatever, from 98.6, and that's going to tell me what temperature it should be at now. Kind of cool. That is the way it works in science, although I will say this is not the actual formula. The actual formula does involve much more complicated math. Okay, here we are at this. We're going to solve this guy for k. Notice we have k's and m's and an r. We have lots of things. Solve for k means to get it by itself. Okay, this one's a little tricky because we have 7 and a k and r and a k. The r is really fascinating that they throw that out so fast. 7k plus 2m equals kr plus 4m plus 3. That's everything. I want to get rid of all the k's on their own. So we have a k over here and a k over here. I need to get rid of some of these k's. I'm going to get rid of 7 k's because I don't really know what to do with the r k's, right? I do, but we're going to keep it simple. So what I'm going to do is I'm going to get rid of the 7 k's here. And I got to subtract 7 k's over here too. Okay. I might as well just tack it on the end for now. So I'm going to end up with, there's nothing left on the left side except for 2m. And on the right side, we have kr. We took away 7k. We still have 4m. But we still have 3. Okay. This is not quite where we want to go, but we're getting there. Now, the good news is all of the k's are on the right side. So now I'm going to get rid of everything that doesn't have a k. I'm going to get rid of the 3 and the 4m. You know what? I'm going to do them both at the same time. I'm going to take away a 3, and I'm going to take away minus 3 and minus 4m. Take both of those away. I'm going to do it over here too. I'm going to write them in a different order. I did 2 steps at once. That's okay with me. So 2m minus 4m is negative 2m, and nothing minus 3 is just negative 3. So I'm going to end up with negative 2m minus 3 equals kr minus 7k. Now this is a tricky step because what we're going to do is right here, we know that we have a 7 times a k and an r times a k. When I have two things that I can't add together, if this was a 5, I could just say, oh, 5k's minus 7k's, that's negative 2k's. I could just add the numbers, but since I don't have a number here, my only choice is to realize that they are both being multiplied by k. And so I can see that and say, hey, that's almost like what happens with parentheses. When I have parentheses, I distribute and I multiply by the r, and I multiply k times 7. And that's actually how we're going to write it. This is called factoring. And again, it's one of the later tricks in math, well, in high school math, that people have troubles with. So if you can get the hang of this trick, then you are ahead of the curve. Okay, it's a very easy trick once you get the hang of it, but it's really weird to switch from this to that. Now notice, if I were to distribute this k right here, I would distribute and I get k times r, k times negative 7, just like here. So I just rewrote it with parentheses. And why is that useful to me? Because it's really the only way to get k by itself. 7k's plus rk's, I don't know how many k's that is. Or minus 7k's, sorry. Point is, this is how we do it. And now I got to get rid of the r minus 7. I just divide by r minus 7. this cancels out. So I end up with, wait for it, there we are, equals K. The bottom line is going to be R minus C. All right. There we go. That's the answer. I solved for K. K is by itself here. K equals all of that. Notice the R and the N, they're still there. All I did was shuffle the numbers where I want them to go, using the rules that we talked about. Add to both sides, subtract, multiply, or divide by both sides by the same thing, and you're fine. Suppose Dune Buggy charges this much per day plus 15 cents per mile. Write a function that describes this. I'm going to do it really fast. So the cost equals $24.95 plus 15 cents per mile. Okay, now we want to find how many miles we drove if we spent exactly this much. Write an equation that would show how many miles you drove if your total rental charge was. Okay, so how many miles did I drive if our rental charge was this? Well, we could say, well, the charge is right here. What if it was 42? Well, I would just write 250 equals 24.95 plus 0.15. And there. So I just took the charge and changed it to 42.50. That's all. Solve the equation. Okay, great. I'll do that. Let's say Control C real fast because I don't want to type it out again. We're not going to. We're going to verify by plugging it in. So here we are. Let's solve this thing. The first thing I would do is take away the $24.95. I have $45 that I have to pay for this whole thing, and $24.95 of it was just to rent the whole thing in the first place. It has nothing to do with the number of miles I drove. So let's get rid of that from the bargain by subtracting $24.95 from each side. That leaves me with, let me grab my calculator because I don't want to mess this up. Get in there. $42.50 minus 24. Okay, it leaves me with $17.55. So that means if $24.95 of my money, my $42.50 that I spent, was to rent the thing in the first place, that means the other $17.55 must have to do with how many miles I drove. And that's what this is saying. 15 cents. Right? 15 cents. So that's a typo up here. Okay. So now I just need to divide both sides by 15. Just going to write that one in. Those two cancel out. I'm back here with whatever 1755 divided by 0.15 is. Let's find out what that is. 5 gives me 117. Okay. How could I check this? Well, I would just have to plug it into the original. I plug it into the original up here. We got C equals in our original formula. This was the setup, and we're going to assume that 117 miles Okay, we went 117 miles. We're going to see what that makes. Okay, C equals 495 plus 15 cents times 117 miles. If I do 117 miles times 0.15, I get 25 plus 17.55, which, you guessed it, adds up to make 42.50. So I just checked by plugging it in. And I noticed, yes, if I drive 117 miles, it ends up being a charge of 42.50, just like we wanted. Okay, now we're solving the last few things. Everything else is just solving equations. So let's do this. I'm going to try to go fast-ish. My first step here is going to be, honestly, just to distribute this and see what I get. Well, nah. We're going to make everything times 3. 3 times as big. Okay, if I multiply everything by 3, then that's going to multiply this to make it a 6. Don't worry about this because it's being multiplied. It's not a separate term because it's being multiplied. Usually I multiply by each added or subtracted thing, but these are not being added or subtracted. They are being multiplied. Same thing here. So I'm going to multiply everything by 3. Here's what I get. 6 times 3x minus 2 equals 3 times x minus 8. And I also have these thirds here. 3. We are. Put this in here real fast, just to remind ourselves how it goes. And back to the text, change it black, which leaves me with 2 times 3x minus 2 equals 1 times 8x minus 8. So that's what it looks like. I multiply both sides by 3. We can see why that's helpful. Now I'm going to distribute the 2 and the 1, so that's going to give me 6x minus 4 on the left side. On the right side, we end up with 1 times anything is itself, so still 8x minus 8. Now here's where you could graph that. Y equals mx plus b, mx plus b. You could graph this and figure it out that way. But why would we do that when I can just solve it? I'm going to take away 6 x's from each side. So I get rid of the x's, then the other numbers that are being added or subtracted, then the other numbers that are being multiplied or divided. So let's get rid of 6 x's. There are none left on the left side. And there are 2 left on the right side. There. Now I need to get rid of the 8. I'm going to add 8. 4 equals 2x. We're basically done. Wait, that's right. Which means x equals 2. A reminder, this is how it's done. When you skip all of this stuff, you're not doing yourself a favor because this is what we're learning, is this method. Algebra, the word algebra, literally means the method. Okay, this one right here, I'm noticing that you have 6 and 8 and 4. I want to find something that they all go into. Oh gosh, let's see. 6 and 4 will go into 12. 8 kind of goes into 12 too. I don't know. You could also go all the way up to 24. I don't really want to multiply by 24. One thing we can do is just multiply by 8 and see what happens. I'm going to pick 8 because 4 goes into 8 already. So if I multiply everything times 8, we'll see what happens. Okay, so I multiply by 8. I get 40 right here. 40. 4x minus 8 plus 8. Over on the right side, we get, I have to make this 8 times as big, that's 24. And then the 1 times 8 is 8. I gotta put in the 6 here, the 8 here, and the 4 here. Got rid of a lot of things that way, so we'll see what that looks like. Now notice 40 and 6, they're both even, so that's going to get smaller instead of 5 and 6. But the good news is the 2 ones on the right, they are completely done. Okay, so now I have 40 over 6. Let's see, that is 20 over 3, right? Because it simplifies. I might just have to do another step. Welcome to the world of algebra. 4x plus 8 equals. Things get fun. We have 24 divided by 8 is 3. And 8 divided by negative 8 divided by 4 is negative 2. So the right side no longer has fractions, but the left side still has a 3 right here. This made the top and bottom each half as big. That's allowed. Simplifying fractions, that's what we've done in the past. Okay, so now I just need to get rid of that 3, so I'm going to multiply everything by 3. This guy, that guy, and that guy. I don't have to worry about what's in the parentheses because this is one big thing being multiplied 20 times. Just like 3 times x is one thing, 20 times this is one thing. It's one term. So multiply everything by 3 times 3 now. I'm going to get, this is going to turn into 60. Divided by 3 is 20. Okay, so I'm going to end up with 20 times 4x plus 8 equals, I have to make this 3 times as big, 9x. Make that 3 times as big, 6. All right, almost there now. Now I need to distribute the 20. 20 times 4 is 80. And 20 times 8 is 160. Oh, goodness. Equals 9x minus 6. Okay, now I'm going to take away 9 x's from each side. That's going to give me 71 x's on the right side, on the left side. 16. but I'm not going to have any x's left over here, just a negative 6. Then I'm going to add 6 to each side. I'm going to really quickly over here. I'm going to add 6 to each side. And if I add 6 to each side, no, I don't want to add 6. I want to subtract 160. I do that, I end up with 71 over here. 160 and 154 is where we're at now. No, negative 166. And I just have to divide by 71, and I'm done. And that's the answer. I don't believe that 166 is divisible by 71. You can double check it, but that's good enough. We can leave it as a fraction. We know the answer. All right, we got this guy getting closer. Look at all this work. We're going to solve the equation for p, so that's the only variable. Okay, so I'm going to just start by distributing the 5, distributing the negative 6. Notice that's a negative 6. It has a negative in front of it. It's very important to be aware of negatives. That's the biggest mistake a lot of newbies make. So I distribute and I get 5 times 3 is 15p. 5 times 5 is 25. Equals 5p minus 6 times p is negative 6p, and minus 24. And then we end up with, let's see, I have a 15 p's and 4 more p's here. 15 plus 4 is 19 p's on the left side. And over here, we have 5 p's minus 6 p's. That's going to end up with negative 1 p. Oh, gosh. I want to literally go on you while I do this one, but oh well. I put on. Almost there. All right. So now I need to get rid of, I'm going to add 1 p to here. That means I have to add 1 p on the other side too, so I end up with 1 more p than there was before, 20. Instead of negative 1 p now, there's none on the right side. There's just the negative 24. All right, now I need to get rid of these guys. I'm going to add 25. So I'm going to get rid of this, and then that, and p will be by itself. So if I add 25, I end up with nothing on the left side except for 20p. And then I added 25 over here, and that gives me 1. Okay, so now I need to get rid of this 20. I divide by 20. I get p equals 1/20th. That's the answer. Another fraction we probably wouldn't have come up just for looking at this. Solve this using, we're on the last page, using the algebraic operations. All right, let's do. First, I have to distribute this guy. 6 goes into 18 and into 6, so I'm going to distribute this guy as well. You'll see. Because this guy, 18 and 6, when I divide them out, and 6 is on the bottom and they're on the top, you're not going to end up with a fraction in the long run. That's why I'm just going to go ahead and distribute and not worry about getting rid of the fraction. It'll take care of itself. Minus 4q plus, no, minus negative times 8. Negative 8 plus 6q equals 12 q minus 5 times 18 is 50 plus 40 is 90. Q. 5 times 6 is 30. Oops, it's minus 90q. Minus 30. I can't forget the fact that the bottom also has a 6. There. There we go. So now, we need to divide 90 by 6. That is 15. And 30 divided by 6 is 5. So those fractions simplify. That's why I didn't bother to get rid of them, because when you multiply it all out, 18 and 6 already goes into those. I add a 5 in there and you get 90 and 30, but 6 goes into them even before I added the 5. There are actually easier ways to do this that would not require too much work. But one step at a time, right? Bruce. Minus 6q or plus 6q equals, right, I'm mentioning that this is actually supposed to be a minus, isn't it? Oops. All right. Okay, so back to the proper thing, 12q minus 15q minus 6, no, 5. Okay, so now I need to get rid of some of these q's. I have 6 q's and negative 4 q's. When I add those together, I end up with 2 q's and negative 8. And on this side over here, we got 12 and negative 15. That leaves me with minus 3 q's. Minus 5. Okay, so now I need to get rid of, well, I want to get rid of the negative q's. I don't like negative numbers, so I'm going to add 3 q's over here so that this disappears, which means this has to get 3 q's bigger as well, which means I end up with 5 q's on the left. And nothing on the right but the negative 5. Okay, getting close. Now I need to get rid of everything over here with this q. I'm going to add 8. I'm going to add 8, and that's going to leave me with nothing but a 5q on the left side. And on the right side, I added 8. 8 and negative 5. I had to make 3. Finally, I divide by 5. Q equals 3 divided by 5. It looks like, and that's the answer, my friend. Notice I can show every step of the way what happened. You can check my work to see if I made a mistake, and I can prove that the answer is mine. So last one, remember we can cross multiply when we have fractions that are equal, so I'm going to cross multiply. It's going to look like this. 9 times x plus 13 equals 8 times 2x minus that's the big trick. Now I distribute. So 9 times x and 9 times 13 makes, well, 9x. 9 times 13 is 90 plus 27 is 117, right? Yeah. Okay. And 8 times 2 is 16. 8 times negative 1 is negative 8. There. Now I'm going to get rid of 9 x's from each side. Get rid of 9 x's, this will disappear, and this will become 7, because 16 minus 9 is 7. 13 equals 7x minus 8. I'm going to get rid of the 8. by adding 8 to each side. So that'll get rid of the 8 on the right, sorry, the left side, sorry, the right side. But this side's going to get 8 bigger, so it's going to be 100. And 25. Added 8. And then I divide by 7 and I get 125 divided by 7 equals X. That's the answer. Would you have guessed that I have to put 125 over 7 into here? That's the only X that works. This is why we must learn algebra. We like to learn these steps because you can't guess that one. I guarantee you, even some of the smartest, fastest, brightest, oh my gosh, I'm great at figuring things out in my head type of people would have big troubles coming up with 125 over 7, unless you do these steps in your head. So hang in there, keep showing your work. Thank you for watching this TED Talk. Have a great day.